Welcome to Math Challenge Problems. Let us have geometry and a problem given in the 2015 International Teenagers Mathematics Olympiad Individual Contest. Let us have this problem. D and E are points inside an equilateral triangle ABC such that D is closer to AB than to AC. If AD is equal to DB, equal to AE, equal to EC, equal to 7 centimeters, and DE is equal to 2 centimeters, what is the length of BC in centimeters? To solve this problem, let us introduce two more segments, that is the perpendicular from A to BC, and let us call the foot of that perpendicular G. Then AG divides BC into two congruent segments. These are BG and GC. Also, AG divides DE into two segments such that the segment DE is divided into two segments that measures 1 centimeter each. Also, let us introduce perpendicular to BC from point D, and let us call the foot of that segment DF. Hence, DF is perpendicular to BC. From the given information, BG is equal to 1/2 of BC, or that is BC over 2. Also, we have segment BF. Since segment DE is divided into two segments that measures 1 centimeter each, then FG is also 1 centimeter. Therefore, the measure of BF will be 1/2 of BC, that is BC over 2 minus 1 centimeter. Also, we can give the measure of segment DF. If we have the measure of segment BD as equal to 7 centimeters, and we have an expression for segment BF, then by Pythagorean theorem, segment DF is equal to the square root of 7 squared minus BF squared, that is BC over 2 minus 1 squared. So DF is equal to the square root of 49 minus BC over 2 minus 1 squared. If each side of equilateral triangle ABC is equal to BC, then altitude AG, since we let AG perpendicular to BC, must be square root of 3 times the length of BC over 2. That is from the 30, 60, 90 degree triangle theorem. Each angle of the equilateral triangle is 60 degrees. Then the measure of angle BAG is 30 degrees. And since AB is equal to BC, then BG is BC over 2. Therefore, AG is BC times the square root of 3 over 2. Since we know that AD is equal to 7 and DE is equal to 2 centimeters, and by drawing segment AG, DE is divided into two segments that are 1 centimeter each, then we have a right triangle such that we can form an expression for AG minus DF. AG minus DF is that segment perpendicular to DE in that triangle form where AD is the hypotenuse. And that is equal to the square root of 7 squared minus 1 squared. And this is 49 minus 1, 48. So this is 4 square root of 3. Also, we know that AG minus DF is equal to the expression for AG, that is BC square root of 3 over 2, minus the expression for DF, that is square root of 49 minus BC over 2 minus 1 squared. By transitive property of equality, we can equate the two expressions for AG minus DF. Then we have BC is square root of 3 over 2 minus square root of 49 minus BC over 2 minus 1 squared equals 4 square root of 3, or we can write BC is square root of 3 over 2 minus 4 square root of 3 is equal to the square root of 49 minus BC over 2 minus 1 squared. Squaring both sides of this equation, we have 3BC squared over 4 minus 12BC plus 48 is equal to 49, and we may expand BC over 2 minus 1 squared as negative BC squared over 4 plus BC minus 1. Simplifying this resulting equation, 48 minus 49 plus 1 is 0, so we can cancel 48 and 49 minus 1. Multiplying all terms of this resulting equation by 4 and simplifying, we will have 4BC squared minus 52BC is equal to 0. 4BC is a common factor, so we can have 4BC times the quantity BC minus 13 is equal to 0. Equating each factor of this resulting equation to 0, we can get BC is equal to 0 or BC is equal to 13. BC cannot be equal to 0, therefore BC is equal to 13 centimeters. That will be all. Thank you for watching. Please subscribe for more math challenge problems.